All right, hi, my math 130s. This is actually going to be, I guess, the second part. So homework, alternate, part 2 for chapter 8, 9. It's actually going to be really short for this one because I just want to introduce composite functions before we start getting into inverse functions, which will be covered in number 4 and so on and so forth. We need to know before we get to inverse functions how to handle composite functions. There will be a similarity between those later, but basically, I just want to introduce this. A composite function, for example, would be stated composite function. It looks like fog. Okay, so this is not, put this in a different color here. Looks like a hole, not a point. If you see a point right here, that means it's a multiplication. Okay, so f times g of x is a multiplication, which is different than what we have here. Okay, instead for this one, f composite g of x is going to be equal to f of g of x. Seems really weird right now, but once you see it, it's not so bad. So let me put this in words on the left side. F composite g of x is equal to f of g of x. Okay, let me save this and then let's go back to the homework alternate assignment so you can read it. Here's number 3. Suppose that the functions q and r are defined as follows. You have function q, which we are going to have in orange. And you have function r, which we're going to have in blue. You want to find the following: q composite r of -5 and r composite q of -5. I'm going to add one in here. Say A, B, and C. For A, we're going to also find q composite r of x. Okay, you know what? I want to add some more stuff, so let me erase this whole thing. Whee. Okay, so I'm going to call this part A, this part B, and then part C and D. We're going to find q composite r of x, and we're going to find r composite q of x. Okay. So let me go ahead and take a quick picture of this because I know I'm going to need it. Trying to save on printing here. Okay, so let me see a picture of that. All right, let's go back to our whiteboard here. Okay, so before I continue with this, let me add one thing. You can also have the composite function g composite f. Let's make that a clear and defined whole looking thing. So g composite f of x And it's not necessarily equal to f composite g of x. Essentially, we're going to have for this one, g of f of x. Okay, so kind of the thing to note here is you always want to write out your general form like this because it's easier to see. Like this is a notation for this. What this first equation is saying is I'm going to plug in x as my input for g. And then I'm going to plug in function g as my input for f. Versus this composite function here, we're saying I'm going to take input x and plug it into f. And then I'm going to plug f of x into g of x. Okay. So let's see this with our problem number 3. We have q of x as negative x plus 1. And we have r of x as 2x squared. So I'm going to start with part C. Let me first just start by writing all the general ones out. So we have A, that was Q composite R of negative 5. We have B, that's R composite Q of negative 5. We have C, that's Q composite R of X. And for D, we have R composite Q of X. Okay. So I actually want to start with part C and D. So let's start with C first. We have Q composite R of X. Let's first start with our definition. What that means is take your outside function Q. Okay. And then you're going to have an input of R. And the furthest most input will be X. Okay. Keep Q as it is. What will R of X be? Well, you have R of X defined right here. R of X is equal to 2x squared. So 2x squared replaces R of X. Okay. Okay. Now, plug 2x squared in wherever you see x in the function q of x. Oh no, here we go. So what that means is we have q negative x is 2x squared now, and plus 1. Let me actually make that color coded. I don't know if it'll help. I'm kind of hoping it will, but see g of x, or sorry, in this case, my second function is r of x. It's equal to 2x squared. That now becomes my input for q of x. So everywhere I see x, I plug in 2x squared. Okay. So what that tells me is q composite r of x is equal to negative 2x squared plus 1. Okay, that's the first part. Let's save that. We're going to go over part D now. Okay, so for part D, we're looking at R composite Q of X, which is going to be equal to R of Q of input x. Okay. So now keep r outside, and you're going to plug in q of x as its input. Q of x is equal to negative x plus 1. Okay. What's going on with my pen here? It's not working. There we go. Okay, still not working. Lord of mercy. Okay, whatever. All right, so there we go. All right, so now wherever you see x in the function r of x, you're going to be plugging in negative x plus 1 instead. So you have 2 times the quantity squared. That quantity that's squared should be negative x plus 1. Now, if you weren't asked to simplify this, you could technically leave it like this, okay? But let's actually expand it just to see what happens. This is 2 times 1 minus x squared, which is 2 times 1 minus 2x plus x squared, perfect square trinomial. So what we find is our composite q of x is equal to 2 minus 4x plus 2x squared. Or you can write it in decreasing order, which I like to do. 2x squared minus 4x plus 2. Now notice Q composite R and R composite Q of X look very different, yes? So these won't always be the same, okay? That's why you have to check them. It depends on which function is the outside function. Let's go ahead and erase this. Let's go over part A. Okay, so for part A, we're looking for Q composite R of -5. Now remember, like if you already had Q composite R of X, you would just plug -5 in for X. Plug in -5 on this side too, and you're done, okay? But let's say that you started from A and B, you didn't do C and D. Okay, well, I know that this Q composite R of -5 is going to be equal to Q, that's the outside function, of R as my inside function. And now my input is going to be -5. Keep your Q of, now you want to put R evaluated at -5 inside of here. Okay, that's 2 times -5, the quantity squared. Okay, you can do that off to the side. 2 times -5 quantity squared, that's 2 times 25, which is 50. So we're evaluating Q at 50. So this is R of -5. Okay. You save that picture. Get rid of that last arrow. I don't know what is happening with this stupid tablet today. Okay, whatever. Let me get rid of this. Okay, so now We have Q evaluated at 50. Come on. Essentially, we have Q here. Plug in 50 for X. So negative 50 plus 1, okay, which is negative 49. So what we found is that part A will be negative 49. Quick check. Let's check it in C. Q composite R of negative 5 should equal negative 2 times negative 5, the quantity squared, plus 1. That's negative 2 times 25 plus 1, which is negative 50 plus 1, which is negative 49. So it checks out. And lastly, part B. See, we're going to use green. Okay, so we have part B, R composite Q of negative 5. So if I were just starting this problem from scratch, not having done part C and D, say, okay, I know that this is going to be R of Q of negative 5. Okay. What is Q of negative 5 going to be? Okay, that's going to be negative, careful here, negative outside, parentheses, negative 5 plus 1. That's 5 plus 1, which is 6. So we're actually evaluating function R at 6. Okay, save that, erase this. Okay, so then R evaluated at 6. It's going to be 2 times the quantity 6 squared. Okay, which is going to be 2 times 36, which equals 72. Okay, so we should get 72 for part B. And you could check it in here. I'm not going to do that, but it should also come out to 72 when you plug negative 5 into part D. Okay, so in the next video, we are going to talk about how the composite is related to inverse functions. Don't worry about that yet. That'll be in the next video.